Riverbend family. I want to tell you how to use a Taylor K-2005 DPD test kit. The Taylor K-2005 is the test kit that we use on all of our maintenance routes out in the field. It's very simple to use, it's very user-friendly, and it's made by Taylor. Taylor is a water treatment company. That's their business. That's all that they do. Consequently, it seems that their test kits are more accurate and more reliable than the other ones on the market. The K-2005 is the go-to test kit for your residential pool. If you're taking care of the pool on your own, you need to have a K-2005 so you can do proper water testing. The other beautiful thing about Taylor's test kits is that they're very user-friendly. If you look at the Taylor K-2005 reagents, you'll notice that they're all labeled and color-coded. The colors match up to the instructions that are in the lid for each different test. So if you'll notice the yellow is the chlorine test. It's labeled and color-coded so that you know exactly what you're testing for with those reagents. This kit is very user-friendly, even though it is an advanced kit that can test for lots of different chemicals. So let's go ahead and get started on a full water test. The first step to any successful water test is taking a proper water sample. You need to make sure that your pool's been running for about 2 hours, and when you collect the water sample, it needs to be at an area of average depth in the pool. That means not the deep end, not the spa, and not the shallow end, but where your pool begins to slope from the shallower end to the deeper end. If you have a play pool, that's going to be in the middle, where the pool goes from 3 feet to 5 feet. So right on that slope, where the shallow end goes towards the deep end, you're going to want to make sure you're away from any jets or returns. Take your water sample bottle, make sure you go at least 18 inches below the water surface before water begins entering the bottle. Take a full sample from 18 inches below the water surface at an area of average depth. That is how you get a proper water sample. Now that we have the water sample, we can begin testing it. If you'll take out the plastic comparator inside of the K-2005, we can start this process. You'll notice that there are two compartments. One is a little bit skinnier and just more rectangular, and the other one is rounded and larger. If you look on the outside edges of both of these compartments, there's different notches with different numbers. This is simply just different amounts of water. You're going to need different amounts of water for each test. The very first test that we do is for chlorine, free, total, and we can also get combined. So the first thing we need to do is take your pool water, take the smaller compartment on the comparator, and fill it up to the 9 mark on the side. Now that you've done that, take the very first yellow bottle. It's R-0011. We're going to need to do 5 drops of that into that water sample we just poured. When you do a drop with any reagent, you need to make sure that the bottle is completely vertical and upside down. This way it ensures that you get a full drop of reagent. If you kind of tilt the bottle to the side or you don't quite have it upside down enough, you may only get half to 3/4 of a normal drop. So we want to make sure that it's completely vertical upside down. Now do 5 drops of the 0011. Okay, immediately follow R-0001 with 5 more drops of R-0002. Now, you can either use the rubber cap provided or use your thumb, put it over the top of that compartment and shake it up. Hopefully the water turns some sort of pink color. This would indicate that you have free chlorine. To figure out how much, you need to either take a white piece of paper or use some sunlight, hold the comparator up into the white piece of paper into the sunlight, and match the pink color to the pink underneath the CL. Should give you some sort of number, like 1.5 to 2 or 2 to 3 or something like this. That reading is what we call free chlorine. Free chlorine is the chlorine in your water that's available to fight off contaminants. Free chlorine should be tested every 2 to 3 days and maintained in the proper range. If you're not sure what the proper range is, please see our chemistry school so that you know exactly where your chlorine needs to be. The next reading that we need to get is for total chlorine. To achieve this, you take the last yellow bottle, it's R-0003, and do 5 more drops into the same sample. Again, either using the caps provided or your thumb, shake up the compartment and compare it by a white background or into some sunlight. This reading is called total chlorine. Total chlorine is telling you the entire amount of chlorine you have in your pool, both the free available chlorine and any chlorine that may be actively tied up with a contaminant and oxidizing or sanitizing it. The last chlorine reading you need to get is called combined chlorine. And what you do simply is take your total chlorine reading and subtract from that the free chlorine reading. So, if your total chlorine is 2 and your free chlorine is 1, then your combined chlorine reading is 1. And what combined chlorine is simply chlorine that's attached to a nitrogen or ammonia-based contaminant and is oxidizing it. Sometimes this combined chlorine can turn into chloramines, at which point you will have to shock the pool to 10 times the amount of combined chlorine. So what that means is if your combined chlorine is 1, you need to shock your pool to 10 parts per million free chlorine in order to break through the combined chlorine. Other solutions to combined chlorine is using shock and swim or regular use of enzymes which will break down nitrogen and ammonia-based contaminants and prevent combined chlorine from occurring. Okay, so that's how we test for chlorine. The next test is the red bottles, and the red bottles are for pH. To test for pH, what you want to do, go ahead and empty out the comparator compartment. You can dump it right into your swimming pool so that the reagents are oxidized. It's not going to hurt anything. Now, after you've sort of rinsed out the comparator, we need to use the larger compartment. We're going to fill the larger compartment up to the top mark, which is 44. The first thing you do once you fill it up to 44 is take the very first red bottle, which is R-0011L. It's the red pH indicator. Again, holding it completely vertically upside down, add 5 drops of the R-0011L to the sample of 44 milliliters. Now, using the rubber cap provided or just the palm of your hand, cover the top of that comparator compartment and shake it up. Once you've shaken up the sample, make sure the comparator is flipped to the right side. This is the side that had the chlorine reading on it and also has the pH readings on it. Now what we need to do is hold up the comparator to either a white piece of paper or into some sunlight, so we make sure we get an accurate comparison. Match the shade of the pH liquid as best you can to the colors provided. So now, typically, your pH will either be in range or it will be too high. That's what we mostly see in the North Texas area. What we're going to do now is pretend that our pH was high. Let's pretend that it was about 8.0. Now, we need to figure out how much muriatic acid we need to add to bring the pH back down from 8 to about 7.4. So to do that, you can either go to our online water testing module, input your pH reading, and it will give you a dosage chart, or we can use the Taylor kit to do what's called an acid demand test. And all you do, it's very simple. Take that second red bottle, it's R-0011L5. It's called acid demand reagent. We take this reagent and we start adding it a drop at a time. Count the number of drops that you have to add in order to get that pH color from the 8.0 back down to the 7.4. Let's pretend that it took 4 drops to get the pH back down from 8.0 to 7.4. What we need to do now is refer to Taylor's treatment tables. The treatment table for the acid demand test is on page 57. The way this table works is, as you can see across the top, there's gallons, and down to the left side, there's number of drops. So if we did 4 drops and our pool is 10,000 gallons, we need to add about 1.15 quarts of muriatic acid, right around 5 cups, in order to bring the pH down from 8 to 7.4. So, now that we know how much acid we need, we can go ahead and add it and correct our pH. pH should be tested every 2 to 3 days. It's very important to keep your pH in range because chemicals do not function properly, especially chlorine. Chlorine is pretty much ineffective at a pH above 7.8. It cannot sanitize. Therefore, when your pH is high, you're at risk of having algae blooms, as well as having waterborne illnesses form in your water because the chlorine can't sanitize. So, check your pH every 2 to 3 days and adjust it as necessary. The last red bottle in the test is called a base demand test. And what I'm going to do now is pretend that our pH was too low. We're going to pretend that our pH was right around 7, so we need to raise it. Just like the acid demand test, if your pH was too low, you would take the base demand reagent, R-0011L, and add it drop by drop until the color increased from the 7.0 up to the 7.4. Let's pretend it took 4 drops of the base demand reagent to get our proper pH level. Now we need to go to page 56. Page 56 is increasing pH using soda ash. This is the treatment table that we need to figure out how much soda ash to add to raise our pH up. So, 4 drops at 10,000 gallons of water, you need about 1.28 pounds of soda ash, or sodium carbonate, in order to raise your pH to a proper level. Now that we know, we can simply take the proper amount of chemical, add it to the water, and know that our pH is going to be okay. That's how you test for pH using a Taylor K-2005. Let's move on now to the next test, which is total alkalinity. Total alkalinity is the green bottles. Before we begin testing alkalinity, we need to empty out the comparator and rinse it. You can do this into your pool. It's not going to hurt anything for the pool to oxidize off the reagents. So go ahead, dump that old water out into the pool, give it a good rinse, and then take your water sample and fill the large compartment up to the 25 milliliter mark. The process for testing alkalinity is called titration, and it's a little bit different than just adding in a few drops and comparing a color. We're going to have to add some drops and wait until one color of our water changes to another. Titration is how we figure out both total alkalinity and calcium hardness. So pay close attention to how this works because it's a little bit tricky. Like I said, the first thing we need to do, fill the large compartment up to the 25 milliliter mark. Alkalinity test is the green bottles. Take the first green bottle, R-0011. It's called thiosulfate. Take the R-0011 and add 2 drops into that 25 milliliter water sample. Now, take the next green bottle, which is R-0008. It's called alkalinity indicator. We need to do 5 drops of R-0008 into that 25 milliliter water sample. Now what I do to get my alkalinity reading is I take the last green bottle, R-0009, sulfuric acid. And I'm going to do it slowly, 1 drop at a time, while I'm swirling my sample. And I'm trying to find out how many drops of the R-0009 it takes to turn this green water into a solid pink color. So let's pretend it took 6 drops for me to change that green to pink. I take the number of drops that it took, multiply that by 10, and that's my alkalinity reading. In this case, my alkalinity reading would be 60 parts per million. Now that I know that, I can figure out how much sodium bicarbonate I need to add to increase my alkalinity back into proper range. So, proper range for alkalinity is anywhere between 80 and 120 parts per million. Preferably, we want to go between 110 and 120 parts per million. So I'm going to add about 50 parts per million alkalinity to my water in order to increase it from 60 to 110. The treatment table for figuring out how to increase your alkalinity using sodium bicarbonate is on page 59. The way this treatment table works is you take in parts per million the amount of alkalinity you need to add and then find the gallons of your pool. So my pool is 10,000 gallons. My alkalinity reading was 60. I need to get to 110, which means I need to add 50 parts per million alkalinity. So 50 parts per million, 10,000 gallons of water, tells me I need to add 7 pounds of sodium bicarbonate in order to bring my alkalinity back into range. Now that I know I need to add 7 pounds of sodium bicarbonate, I simply go, get the proper amount, and broadcast that over the surface of my pool. Total alkalinity should be tested once a week and adjusted as necessary. If you do things right, total alkalinity should remain in range for about 4 to 6 weeks before you have to readjust. Under special circumstances like heavy rains and heavy use, though, you may have to adjust alkalinity at a more frequent basis. Okay, so we're done with alkalinity. Go ahead, dump that sample back into the pool and rinse the comparator out. Now we're going to test calcium hardness. Calcium hardness is the blue reagents. And if you look at the instructions for calcium hardness, you will notice that there's two different ways to do this. The first way is listed in 5 steps. The second way is at the bottom of the instructions for calcium, and it says when high CH is anticipated. The second way is the easier way to test for calcium. With calcium, you don't need to get an exact number like 410.3357. We need to know a good range because we're just trying to keep our calcium within a certain range. So the second way for testing calcium hardness reduces the amount of drops we have to use in half. And we have to use quite a few drops. If you'll notice on the first set of instructions for calcium, the very first reagent you have to add 20 drops of that. That sounds crazy. So we like to do it the second way, which is when high calcium hardness is anticipated, which in the North Texas DFW area, we can anticipate high levels of calcium hardness. Now, to test for calcium hardness, we're going to use the large compartment again. Make sure it's been rinsed out. Take the water from the pool sample that you got and fill up the large compartment to the bottom notch, which is 10 milliliters. Now, take the first blue bottle, R-0010, and add 10 drops. The next step is to take R-0011L, which is the calcium indicator. It's a purplish looking liquid. We need to add 3 drops of that. Once you've added the 3 drops, we need to, again, swirl that sample. Once the sample has been swirled and the pinkish purple color is uniform, we can begin doing our titration. Take the last blue bottle, R-0012, and while you're swirling the sample, very, very slowly, add a drop at a time of R-0012. Count the number of drops it takes to turn that pinkish purple color into a solid blue, like the color of the Taylor test kit case, or like my shirt. Let's pretend it took 9 drops. Each drop represents 25 parts per million calcium hardness. So, if you have 9 drops, multiply 9 by 25, and that'll give you a reading of 225 parts per million. That will put you in the proper range of in between 175 and 400 parts per million. Calcium hardness should be tested at least once a month. If you've been shocking heavily like in the summer, it's a good idea to test it 2 to 3 times a month just to make sure you don't go anywhere where you might need to use a sequestering agent to help prevent calcium scaling. Now, let's pretend that we had tested the calcium and it was at 100 parts per million. That's just too low. When calcium hardness is too low, you're at risk for your pool foaming, as well as your pool water being corrosive to your equipment and other surfaces. So we need to make sure we do have a proper amount of calcium. Too little calcium, corrosive, aggressive water. Too much calcium, water that likes to dump calcium scale on your tile and your plaster and everywhere else. So there's a happy balance here. We need to make sure we have it between 175 and 400. So if I test my calcium hardness and it's at 100 parts per million, I need to add some calcium. I'm going to need to add about 100 parts per million calcium so I can get it up to about 200. 200 is a good range for calcium. The treatment table to increase calcium hardness in your pool water is on page 62 in the Taylor Handbook. So, I'm at 100 parts per million right now. I need to add another 100 parts per million to get to 200. Using this chart, I go down to 100 parts per million and go over to 10,000 gallons. I need to add 12 pounds of calcium chloride in order to raise my calcium hardness from 100 to 200 parts per million. Calcium chloride can simply be broadcast across the surface of your pool. Okay, so the last thing that we can test for with the Taylor K-2005 is cyanuric acid. To test for cyanuric acid is a little bit different than all the other tests that we've done because we need to mix a solution together. So, what we're going to do is take the dropper bottle provided inside of the test kit. If you look at the front of it, you'll notice that there's 2 notches, 7 and 14. To make this proper solution, we need to fill the dropper bottle with pool water to the 7 mark. Then, we need to take the R-0013 cyanuric acid reagent and fill that dropper bottle up to the 14 mark. You have 2 bottles of 0013 inside of the test kit, and that should give you about 6 to 7 tests. Cyanuric acid only needs to be tested once a month during the spring and the fall, and probably about twice a month in the summertime. So, these bottles should last you quite a while, even though it seems like it won't go so far because you have to use so much of it every test. Okay, now that we have the proper amount of chemical inside of the dropper bottle, replace the cap and shake it up for about 20 to 30 seconds. Let it settle for about 15 to 20 seconds. Now, take the comparator and look down the very top of the smaller compartment. At the bottom of the smaller compartment, you will see a black dot. To get our cyanuric acid reading, we need to take the dropper bottle, flip the top, and then while we stare at the black dot at the bottom of the comparator, slowly add in the solution that you made until the black dot completely disappears. Once you've made the black dot completely disappear, and when I mean completely gone, I mean you cannot see it at all. You cannot even convince yourself that you can see the black dot. Once you've gotten to that point, take the comparator, look on the front side, on the side of the smaller compartment, there's a thing that says CYA. Wherever the liquid stops next to that number under CYA, that's your cyanuric acid reading. Hopefully it's between 30 and 50. 30 and 50 is the ideal cyanuric acid range. It's where your chlorine functions as well as it can while being protected from the sun's UV rays. When cyanuric acid begins to go above 50 into the 60s and 70s, your chlorine's ability to sanitize begins to diminish. Once cyanuric acid reaches a level of 90 or higher, your chlorine is considered completely ineffective at sanitizing, thus making your pool a health hazard. So, if you test above 90 parts per million cyanuric acid in your pool water, you need to drain about 30 to 50% and refill. This will dilute the cyanuric acid back into proper range. Now you know how to use a Taylor K-2005 test kit. And let me summarize on the testing frequency that you should be using to test your pool water. Both free chlorine and pH should be tested every 2 to 3 days. Total chlorine and total alkalinity should be tested weekly. Cyanuric acid and calcium hardness should be tested every month. I hope this has been helpful. Now you can use your Taylor K-2005 test kit to get proper results to input into our online water testing module so you can keep an accurately treated pool, a trouble-free pool, all season long. I hope this video has been helpful, and as always, thank you for choosing riverbendpoolsupply.com for all your swimming pool needs.